The next one says, using the same relationship of red to blue from above, create a table that models the relationship of the three colors, blue, red, and purple, which is the total of the blue and red together. Let B represent the number of gallons of blue, R is going to represent red, and T is going to represent total number of gallons of the purple paint. Then write an equation that models the relationship between the blue paint and the total amount of paint. Okay, so let's start to fill this in. We remember from the last one, every time we have 1 gallon of blue paint, we have 4 gallons of red paint, so 1:4 ratio. And so that would give us a total of 5 gallons here. Okay, 2 times 4, 8, and that gives me a total of 10. 3 times 4 is 12, gives me a total of 15 gallons of paint. 4 to 16 gives me a total of 20 gallons of paint. And 5 times 4 is 20, which gives me a total of 25 gallons of paint. Okay, now they want us to do an equation talking about the relationship of blue to total. Okay, blue paint to total. So what are we noticing about the relationship from blue to total? Well, 1 times what is 5? 1 times 5 is 5. Okay, and we can check that with another one. Is 2 times 5 10? Yeah, 3 times 5 is 15. So the constant relationship here, to make sure that we did it correctly, it should match on all of them. 5 times 5 is 25. So the equation, we take a blue, we can multiply it by 5, and that's going to give us our total. Okay, you can also just write that as B, well, the number should go in front. 5B equals T. That works too. The value of the ratio of total to blue. Thinking back to value, I can first write it as a ratio. Total 5 to blue 1. So when I want that in value form, first number over second number, 5 over 1. And then how is the value of the ratio related to the equation? Well, the value is used to find the total paint by multiplying it with the blue, just like we multiplied the blue by 5 to get the total. So I'm going to write something like that. The value is used to find the total by multiplying Okay, so the value is used to find the total by multiplying it with the blue. In our next example, one thing I noticed in the directions, again, you guys, is they really like tricking us and writing the ratio backwards of the way that they have it in the chart. So don't be tricked. Make sure that you read and notice which numbers correspond with which. During a particular U.S. Air Force training exercise, the ratio of the number of men to women was 6:1. See here they have men to women, and down here they have women to men. So I like to color code. Men corresponds to the number 6, women corresponds with the number 1. So I'm going to put 6 under men, women 1, just to make sure I keep it in the correct order. Use the ratio table provided below to create at least 2 equations that model the relationship between the number of men and the number of women participating in this training exercise. So what do you notice about the numbers here? What kind of relationship can we describe? It looks like if I take the number of women, I'm multiplying it by 6 to get the number of men. Right? So all the way down it should be the same. So one thing, while I'm noticing that, it's helpful for me to write it down now, that I noticed the number of women, I had to multiply that by 6 to get the total number of men. Now if I wanted to go backwards and I wanted to figure out how many how many women, I would have to take the number of men, and I would have to multiply that by 1/6 to get a smaller number, which was the number of women. Okay, it's the same thing as dividing by 6, but we're focusing on writing a multiplication equation so we can multiply by 1/6. So we can complete our chart. So I know if I have 2 women, again, times 6, that would give me 12. 3 women times 6, that would give me 18 men. 4 women times 6 would give me 24 men. 5 women times 6 would give me 30 men. So now if 200 women participated in the training exercise, use one of your equations to calculate the number of men. So here I need to know the number of men. I have the amount of women. So I'm looking for an equation where how to find the number of men. So that would be this one here. So I'm just going to write that down here again. Women times 6 will allow me to find the number of men. So now I know the number of women. There are 200 women, so I'm going to replace that W with the number 200 times 6. Okay, and what is that, you guys? Well, 2 times 6 is 12. Add those 2 zeros back on. So my answer is 1,200 men. In exercise 5, Malia is on a road trip. During the first 5 minutes of Malia's trip, she sees 18 cars and 6 trucks. They're not going to trick me. I know I'm just color coding, so I don't get them mixed up on the chart. Assuming this ratio of cars to trucks remains constant over the duration of the trip, complete the ratio table using this comparison. T is going to represent trucks, C will represent cars. So the ratio here, again, they're saying trucks to cars. When they give it to us in the problem, it's listed as cars to trucks. So that's why I keep reiterating that. They're purposefully mixing them up. So make sure that you are recognizing what number correlates with what unit. So 18 cars to 6 trucks. So I'm putting that backwards to model over here, how they have it from trucks to cars. Now I can see the relationship of trucks to cars. So I noticed that 18 is already filled in on the chart, and I recognize that when she saw 18 cars, she saw 6 trucks. So I can go ahead and I can actually plug in that number 6 right over here in the trucks column. And that shows me my 6 to 18 ratio right here. So what kind of relationship are you noticing? What did I have to multiply 6 times what to get 18? 6 times 3 is 18, right? So that allows me to fill in the rest of my chart knowing that constant. So 1 times 3 is 3. 3 times 3 is 9. 12 times 3 is 36. Now this one I have to go backwards. I'm multiplying by 1/3 or dividing by 3, same answer. So that would give me 20. Okay, what is the value of the ratio of the number of cars to the number of trucks? So cars, 3, to trucks, 1. That's the ratio, but to make it a value, I do 3/1. What equation would model the relationship between cars and trucks? So what relationship did we notice? We noticed that trucks times 3 gives me the number of cars. And then when we had to find the opposite, like here, we took the amount of cars and we multiplied it by 1/3 to get the amount of trucks. When I write it like this, you guys, without the little multiplication symbol, the number should go in the front. So that's why I kind of wrote that a little bit backwards. You could also write C times 1/3 equals t. That's fine too, but if you're taking away that symbol, just move the number to the front of the letter in the equation. At the end of the trip, Malia had counted 1,254 trucks. So how many cars did she see? Okay, so let's look at the equation that we figured out. If we know the number of trucks, so that would be like in this column here, we multiplied it by 3 to find the number of cars. So, and that's what we wrote here. We did trucks times 3 equals cars. So now we know the number of trucks. There's 1,254 trucks. So we're going to multiply that by 3 to get how many cars she saw. So I'm going to write that off to the side here. Go ahead and pause the video while you do your multiplication. And then let's check our answer together. Press play when you're ready to check. Guys, I got 3,762. So 3,762 cars is how many that she saw. For our final exercise, I'd like you to go ahead and try to solve this on your own. So first you're going to fill out the table. Then it asks you to find the value of the ratio of the number of minutes to the walking to the number of minutes running. And then here it asks you for an equation. So go ahead and do this on your own and press pause while you're solving exercise 6, and then press play when you're ready to take a look at what I got. Okay guys, let's check our answers. So one thing I noticed right away when I saw the numbers 10 and 2, I said to myself, oh, well 10 divided by 5 gives me 2. So if I'm comparing running to walking, I'm dividing by 5 or multiplying by 1/5. If I'm going the opposite way and I know like in this example, if I know how many minutes walking and I want to find how many minutes running, I'm multiplying by 5 times 5 because 2 times 5 is 10. Okay, this was the only area where they gave us both, so that's where that's the two numbers that I examined, the ratio I examined to determine the relationship. So as I filled in the rest of the numbers, I got 5, 20 to 4, 40 to 8, and 50 to 10. So I noticed what is the value of the ratio walking to running. So I said walking 1 minute to running 5 minutes, and when I write that as a value, I got 1/5. And the bottom part, what equation could you use to calculate the minutes spent walking? So that's what I was talking about up here. If I know how many minutes I spent running, like 10, I recognize that I divide by 5 or multiply by 1/5. Okay, so I take whatever this number is for running, like 10, multiply by 1/5, and that will give me how many minutes walking. So how'd you guys do on that one? Pretty good? All right, guys, so that is the end of our lesson today. Lesson summary: the value of a ratio can be determined using a ratio table. This value can be used to write an equation. So we did a lot of that today, recognizing the value. Are we multiplying by a whole number because our numbers are getting bigger, or are we multiplying by a fraction because our numbers are getting smaller? The multiplication table can be a valuable resource to use in seeing ratios. Different rows can be used to find equivalent ratios. And that's what we've been doing here. Noticing the value can allow us to determine these other equivalent ratios. In your problem set today, you guys have 2 problems that's asking you to examine the value of the ratio. I really recommend, if possible, having any color-coded pens like I was using in our lesson today is really helpful for you to kind of box in numbers that correspond with what unit. For example, white sugar or brown sugar, I would color code the number that corresponds with white sugar, blue, okay? So for just to model that for you, like 1 cup of white sugar and 3 cups of brown sugar. That way when you're writing it here, you're checking, okay, brown, that's 3. I'm gonna put 3 right here. So that just so you don't get mixed up. That's just a really good way to figure out which goes where and you don't flip-flop them. And you can do the same thing in the directions of the problem set. Okay, guys, good luck.